This is our Monorail test rig. This is the test rig that's used to conduct ASTM impact tests. It consists of a head form, an anthropometric head form, which has got the dimensions of your head. It's made of solid magnesium, and what it does is it resembles what your head would do in an impact. At the center of mass of this head form, we have an accelerometer. The accelerometer is capable of measuring the G's, or gravitational force, gravitational units, that your brain would see in the event of an impact. And immediately upon impact, we use a velocity gate to measure how fast the head form is falling and how fast it strikes the anvil surface. Once the velocity gate has been triggered, then our data acquisition system collects the data at a rate of 10,000 samples a second. And we condition the signal, we filter the signal, and we actually present a peak head form acceleration value. And that's the value that we use for the pass-fail criterion of the ASTM standard. And at present, the pass-fail criterion for ASTM F1163, which is the equestrian helmet standard, is 300 Gs. That means that no impact is allowed to have a peak head form acceleration of greater than 300 Gs. Now let's look at the results for the ASTM helmet. We can see that as a result of the impact, the head form saw 224 Gs of acceleration. That's well below the 300 G requirement of ASTM. Okay, so we've seen how an ASTM helmet performs when subjected to a flat anvil impact. Let's take this Caliente helmet, and first let's take a look at it. If we look inside, we don't find expanded polystyrene. What we find is a very thin layer of vinyl nitrile foam. Now this thin layer of foam, when subjected to an impact, is going to bottom out. That means it's going to crush all the way down to almost zero thickness, and it's not going to be very effective at absorbing energy. And what that means then is once a material has bottomed out, all of those impact forces end up being transmitted directly to your skull. But now let's take it up. I don't want to take it up to the same height as an ASTM test because I know that this material is not as effective as expanded polystyrene. So I'm going to take it up to approximately half the height of an ASTM test, or approximately 3.5 feet. So let's take a look at the test and see what happens. Let's look at the test results for the Caliente flat anvil impact. As a result of this impact, the head form saw 548 Gs. That's well above the 300 G limit as specified by the ASTM standard. And that means that in this particular impact, a tremendous amount of force was applied to the helmet, and you have a tremendously high risk of sustaining some kind of a serious head injury if you were wearing this helmet in the event of an accident. So now we've seen the test and seen the results. We can't see any damage on the helmet, but if we look at the graph, we can see that it's 548 Gs. That's approximately 1.5 times the maximum allowable limit by ASTM. And remember, we only dropped this helmet from half the height of an ASTM standard test. Compare that to the ASTM approved helmet, which we dropped from 7 feet and really only produced 250 Gs and met the standard. This Caliente helmet will not meet the ASTM requirements, And what it also means for you is that the impact forces are going to be transmitted directly to your skull and brain and start to cause injury. In addition to the flat anvil test, the ASTM standard also requires hazard anvil impact tests. And you can see here's the hazard anvil. It's a very sharp and aggressive edge, and it's designed to simulate a horse's hoof or the edge of a railing. Now let's take a look at a couple of impact tests using this hazard anvil. Here's the test results for the ASTM hazard anvil test. And you can see that the peak headform accelerations were slightly over 110 Gs. So well below the 300 G pass-fail limit set by the ASTM. Now let's run the exact same test, the ASTM equestrian hazard anvil, with the Caliente helmet. Now remember, the Caliente helmet only has that thin layer of vinyl foam and doesn't have the EPS that we see in the ASTM helmet. So let's take a look at the Caliente helmet after the hazard anvil test. You can see here the signs of a significant impact, and the shell is actually cracked and fractured. But what's most important to look at is the inside of the helmet. And I want you to look in here, and you can see this line. That's the anvil that's gone all the way through the shell and all the way through the foam and left a mark on the foam. That means that if you were wearing this helmet, you would have a similar mark to this on the side of your head. Let's take a look at the Caliente hazard anvil tests. And we can see that the acceleration rises rapidly and gets to 350 Gs. That's 50 Gs greater than the maximum allowable limit specified by the ASTM standard. So this helmet would fail the ASTM hazard anvil test.